This is 7.4a, finding exact values of the trigonometric functions secant, cosecant, tangent, and cotangent. And this is from OpenStax, Algebra, and Trigonometry. So before we jump into this section, we need to review a few things. First, we've defined sine and cosine in terms of the unit circle. And so remember back to our previous lessons, we defined that the sine of t on the unit circle is equal to y, and the cosine of t on the unit circle is equal to x. And we can see that because when we have on the unit circle, we have this is 1, right? And this is the value of y, and this is the value of x. And we know that sine, so, is opposite over hypotenuse. So that is y over 1, which leads to y. And ka, adjacent over hypotenuse, is x over 1, and that gives us x. So we've defined sine and cosine in terms of the unit circle as sine of t is equal to y, and cosine of t is equal to x. Let's also remember that we've defined the cofunctions in terms of the other functions. And so it's been a little while since we've used these, so let's review them. We said that cosecant of t is equal to the inverse of sine t. The inverse of sine t. So if we go back to the right triangle, if we go back to the right triangle, sine is equal to opposite over hypotenuse, then cosecant is equal to the hypotenuse over the opposite. So it's the reciprocal, right? It's the inverse. So we can say that cosecant of t is equal to sine inverse of t, which is the same as 1 over sine t. And then the same rules follow for the other cofunctions. Secant of t is equal to cosecant inverse of t, which is equal to 1 over cosine of t. And cotangent of t is equal to the tangent inverse t, which is equal to 1 over tangent t. Okay, so if you're not solid on these, you need to go back and you need to review this. You need to remember which ones are the reciprocals of the other ones. Okay, so let me go back real quick to what we're reviewing before we jump in. We're reviewing that sine of t is equal to y, and cosine of t is equal to x. And then that cosecant of t is equal to 1 over sine t, secant of t is equal to 1 over cosine t, and cotangent of t is equal to 1 over tangent t. Now, you will notice that we did not have a definition for tangent in terms of the unit circle. So let's come up with a definition for tangent on the unit circle. So here we have a unit circle, and we have an unknown angle and unknown coordinates for that angle. It's just a generic, but we do know it's on the unit circle. So this terminal angle, the length of it is 1. This terminal side of the angle is 1 because the hypotenuse has to be 1. And so let's come up with a definition for the tangent. Okay, so we know that tangent of t is equal to, right, TOA, tangent is equal to opposite over hypotenuse. Okay, so if we turn this into a right triangle, the opposite is going to be the y value over, not hypotenuse. This is when I need you guys in class with me to catch me before I keep going and make mistakes. Opposite over adjacent, right? And the adjacent is the x value. So tangent of t on the unit circle is equal to y divided by x. Y divided by x. Putting in what we already defined, remember on the few slides ago we said that y is equal to sine of t and x is equal to cosine of t. We can also substitute those in here. So tangent of t is equal to sine t over cosine t. Okay, so we can define tangent in terms of sine and cosine on the unit circle. Now, we need to look at some things. We need to look at some domain here because we have a fraction, right? So there is a value that x cannot be, What can x not be? X cannot be 0 because we cannot divide by 0, right? And we cannot have a 0 on the bottom of this. So cosine of t cannot be 0. Okay, so keep those in mind when you're working with tangent, that your x cannot be 0 and your cosine of t cannot be 0. And of course, x and cosine of t are the same things. Okay, so that's how we define tangent in terms of the unit circle. So let's look at cosecant on the unit circle, and then we'll look at secant on the unit circle and cotangent on the unit circle. So we remember we defined these as the inverses of our other trigonometric functions. So let's start with cosecant. We defined cosecant of t is equal to sine inverse, that's an inverse of t. Cosecant t is equal to sine inverse of t, which is equal to 1 over sine t. Sorry, it's a little sloppy there. Okay. Now, we know that sine of t is equal to y. Therefore, we can say that cosecant of t is equal to 1 over y. Now, once again, we need to look at what y cannot be. Y cannot be 0 because we cannot divide by 0. Okay, so cosecant of t is equal to 1 over y. Y cannot be 0. Let's look at secant. Secant of t is equal to the cosine inverse of t, which is equal to 1 over cosine of t. And we know that cosine of t is equal to x, so that's equal to 1 over x. Okay, so secant of t is equal to 1 over x, but we need to exclude 0 as our value for x. Okay, secant t is equal to 1 over x. And then cotangent. Cotangent of t we defined as tangent inverse of t. Sorry, that should be a 1, not a t. Tangent inverse of t. And we said that tangent is y over x. So the inverse of that, the reciprocal of that, is going to be x over y. Cotangent of t is equal to x over y. And then what is our limitations here? Our limitation is that y cannot equal 0 because we cannot have a 0 on the bottom. Okay, so that's how we define cosecant, secant, and cotangent on the unit circle. Let's go ahead and summarize all this in one table or one chart. And I suggest that you write this out nice and neatly and keep it in a handy spot, whether it's in the front of your binder or in the front of your notebook. Just keep this really handy. And so let's go ahead and start with sine of t, cosine of t, and tangent of t. Okay, so sine of t, if t is a real number and x, y is a point where the terminal side of the angle of t radians intercepts the unit circle, then sine of t is equal to y, cosine of t is equal to x, and tangent of t is equal to y over x, but of course, x cannot be 0. Okay, now we're going to use these to summarize our cofunctions. So we have cosecant of t, secant of t, and cotangent of t. Okay, so cosecant is the inverse of sine. So instead of y, we're going to have 1 over y. And then y cannot equal 0. And for secant, we define secant as inverse of cosine, so it's 1 over x, but x cannot equal 0. And then cotangent is the inverse of tangent, so we're going to take the reciprocal of this one, which means cotangent t is x over y, and y forgot that slash there. Y cannot equal 0. Okay, so this is a summary of the trigonometric functions on the unit circle. Like I said, keep this in a handy place, and actually it would be best if you memorized it. I'm hoping that as you use these, you'll memorize them. But until then, keep it nice and handy. So let's do a few problems with these, with this concept of the different functions on the unit circle. So example 1, the point -3, 2, 1/2 is on the unit circle as shown in the figure. Find sine t, cosine t, tangent t, cosecant t, secant t, and cotangent t. Okay, so we're going to use this ordered pairs in order to find the values, the exact values of all these, right? Because we're using exact values, we're going to leave the radicals there. Okay, so let's go ahead and start with our easy ones. We're going to start with sine of t, and sine of t is equal to y. Since we have our ordered pairs, we know that our y is 1/2. Okay, and then we're going to find our cosine of t, which we know is equal to x. And in the ordered pair, the x is -√3/2. And then we're going to find our tangent. Tangent of t is equal to y over x. Now this is where it's going to get a little complicated because we're going to have a complex fraction here. We have 1/2 as our y divided by -3, sorry, -√3/2. Okay, so we have a fraction divided by a fraction. Now think way back to pre-algebra, maybe even like 5th grade, and when you have a fraction divided by a fraction, you can just rewrite that as a division problem. 1/2 divided by -√3/2. And then when you're dividing by a fraction, you rewrite it as a multiplication problem with the reciprocal of the second fraction. Okay, so that's going to equal, let's come over here, 1/2 times 2, -2 over square root of 3. Okay, and then I can cancel the 2's. So I get -1 over the square root of 3 as the tangent of t. Now, this is the value of the tangent of t, but I need to rationalize this denominator. So I'm going to multiply this by square root of 3 over square root of 3. And that gives me -√3 over 3 as the tangent of t. Okay, so I have found the sine, I have found the cosine, and I have found the tangent. Now I need to find the secant, cosecant, and cotangent. And those are going to be easy now that I found all these because I'm going to take the reciprocals of them, right? So I'm going to start with cosecant of t, which is the reciprocal of the sine. Okay, so it's going to be 1 divided by 1/2, which means I flip the 1/2 over and I get cosecant of t is equal to 2. Then I'm going to find the secant of t, right? I'm going to take the reciprocal of the cosine, -√3/2. So it's going to be -2 over the square root of 3. Now once again, this is the value of the secant of t, but I need to rationalize that denominator. So square root of 3, square root of 3, and I get -2 square root of 3 over 3 for the secant of t. And then I need to do the cotangent. And so I'm going to take the reciprocal of the tangent. Okay. Now if I take the reciprocal here, I'm going to end up with a radical on the bottom, and I'm going to have to rationalize the denominator again. So what I can do is I can just go back before I rationalize the denominator of the tangent, and I can take the reciprocal of this. Okay, so the tangent is equal to -1 over the square root of 3. So I can take the reciprocal of that, cotangent of t, flip that over. I have to keep the negative, and it's -square root of 3. And there's my cotangent. Okay, so that's how you would use the ordered pairs, the x and the y, to find sine, cosine, tangent, cosecant, secant, and cotangent on the unit circle. Okay, you're going to go ahead and try this. The point, square root of 2 over 2, and negative square root of 2 over 2 is on the unit circle as shown in the figure. Find sine, cosine, tangent, cosecant, secant, and cotangent of t. Go ahead and pause the video, work through each of these using your x and your y, and then come back and make sure you got it correct. So let's work through this together. So the first one, I'm going to start up here, give myself some room. Sine of t is equal to the y. Y is negative square root of 2 over 2. 2 over 2. Okay, so there's my sine. And then my cosine of t is equal to the x, which is positive square root of 2 over 2. Okay, there's my cosine. Now I need to find my tangent. Tangent of t, and this is where it gets a little messy because I need to have my y over my x, or I need to have my sine t over my cosine t. So my sine t is negative square root of 2 over 2, and that is over square root of 2 over 2. Okay, so I'm going to rewrite this as a division problem, which equals negative square root of 2 over 2 divided by square root of 2 over 2. And then, because I'm dividing by a fraction, I'm going to rewrite as a multiplication problem. Negative square root of 2 over 2 times the reciprocal, which is 2 over the square root of 2. Ooh, I like the way this is looking because I can cancel out this 2 and this 2. And I can also cancel out this square root of 2 and this square root of 2. And all I'm left with is negative 1. So the tangent of t for this angle is negative 1. Okay, so I found my sine, my cosine, and my tangent. Now I can use those values to find my cosecant, secant, and cotangent. So let's start with cosecant. Cosecant is the inverse of sine. So I'm going to take this and flip it over. Negative 2 over the square root of 2. And then once again, I need to rationalize that denominator. Square root of 2, square root of 2. So multiply this out. Negative 2 square root of 2 divided by 2, and then I can simplify because there's a 2 on the top and the bottom, and I get negative square root of 2 for the cosecant. Okay, and then let's find the secant. Secant of t is the inverse of cosine, square root of 2 over 2, and then, oops, sorry, I needed to flip that over. 2 over square root of 2. Once again, I need to rationalize my denominator, and I get 2 square root of 2 over 2. Those cancel out, and I get positive square root of 2 for the secant. And then cotangent of t is the inverse of, here's my tangent. My inverse is, or my tangent is negative 1, and the inverse of negative 1 is still negative 1. So in this case, my tangent and my cotangent are the same. Okay, so check over your answers. Check to make sure that you got the same answers that I did. If you did not, go back through step by step and check to find where you went wrong. Make sure you understand how to do these. If you need help, please don't hesitate to reach out to me. Okay, let's do another one, but let's work in radians this time. I guess last time we didn't have degrees or radians. We were just given the x and y. So let's work with when t is equal to pi over 6. Okay, t is equal to pi over 6. So what I'm going to do is I'm going to just kind of sketch this out. I know that pi over 6 is going to give me a 60, 30, 90 triangle. Okay, and I know that the ratios, sorry, I drew that sideways, didn't I? There we go. Pi over 6. I know that the ratios of a 30, 60, 90 triangle are 1, 2, square root of 3. But because we're on the unit circle, I know that the hypotenuse has to be 1. So I need to divide all of these by 2 in order to get everything into the right ratio. So I need to divide this by 2. That gives me 1. Divide this by 2. That gives me 1/2. Divide this by 2. That gives me square root of 3 over 2. Okay, so these are the values of my x, my y, and my hypotenuse for when t is pi over 6. Now I'm going to use those values to find sine, cosine, tangent, cosecant, secant, and cotangent. So let's start with sine. Sine of t. We know that sine is equal to y. And our y is 1/2. Okay. So that is our solution for sine. Okay, cosine of t is our x. Our x is square root of 3 over 2. There's our solution for that. Okay, now we need to find tangent. tangent of t is equal to y over x. So our y is 1/2. I'm just going to go ahead and write it as a division problem right away. 1/2 divided by square root of 3 over 2. I'll rewrite that as multiplication. 1/2 times 2 over the square root of 3. Can cancel those out, and I get 1 over the square root of 3, but I need to rationalize that denominator. Square root of 3, square root of 3, and I get square root of 3 over 3 as the tangent of pi over 6. So then I need to go into my cofunctions. So the sine, the reciprocal of sine is cosecant. So I know I'm just going to flip this over. Cosecant of t equals 2. And secant of t is equal to 2 over square root of 3. But I need to rationalize the denominator. Square root of 3, square root of 3. 2 square root of 3 over 3. There's my secant. And then cotangent. Cotangent of t is equal to, now if I flip this over, I'm going to have to rationalize the denominator again. So I'm going to go back before I rationalize the denominator. Tangent is equal to 1 over square root of 3, and I'm going to take the reciprocal of that, which is square root of 3. Cotangent is equal to the square root of 3. Okay, so you are going to now try this on your own. Try it number 2. Find sine, cosine, tangent, cosecant, secant, and cotangent when t is equal to pi over 3. To get you started, I'm going to go ahead and sketch pi over 3, right? Oh, that's a horrible sketch there. Sorry, guys. We know that's a 60-degree triangle, which means our ratios are 1, 2, square root of 3. Okay, but since we're working on the units, wow, I am not doing well with triangles today. Since we're working with a unit circle, we know that the hypotenuse has to be 1. So we have to divide every other value by 2. Square root of 3 over 2 and 1/2. Okay, and so these are your values of y and your values of x. Okay, pause the video, try to find all 6 values of the trig functions, and then come back and make sure that you did it correctly. So let's start with the sine of t. Sine of, actually, we don't even have to put t in here. We should be putting sine of pi over 3 in there. I should have done that on the last example. The sine of pi over 3 is equal to the y, and y is square root of 3 over 2. Okay, so that's our solution there. Then we'll do the cosine. Cosine of pi over 3 is our x, which is 1/2. Okay, there's our solution for cosine. And then tangent of pi over 3 is equal to y over x, which is y divided by x. So square root of 3 over 2 divided by 1/2. Rewrite this as a multiplication problem. 2 over 1. And I can get rid of these 2's, and I'm left with square root of 3. So the tangent of pi over 3 is square root of 3. Now I'm going to use these to find cosecant, secant, and cotangent. So cosecant of t is equal to 2 over the square root of 3, and I need to rationalize that denominator. Always, always, always rationalize the denominator. 2 square root of 3 over 3. There's my cosecant. Secant, oops, and I should have put pi over 3 here. Secant of pi over 3. I'm so used to working with t. Okay, so the secant is the inverse of that, so it's going to be 2. And then cotangent of pi over 3 is the inverse of this one. But once again, if I take the inverse here, I'm going to have to rationalize the denominator. Actually, we don't have one where we went back to rationalize, so we are going to have to use that. It's going to be 1 over square root of 3. Let's go ahead and rationalize that, and we get square root of 3 over 3, and that is the value of the cotangent. The cotangent of what is it? Pi over 3. Okay, so check your answers. If you missed any, go step by step through them, find out where you went wrong. Maybe I went wrong. Let me know if I made a mistake. Like I said, I'm used to you guys finding my mistakes as I make them. And then before you go, what I want to do is I want to summarize the exact values of trigonometric functions of special angles in quadrant 1. Okay, so we're dealing with quadrant 1. Why is that important? Well, we know that in quadrant 1, if we're working in quadrant 1, we know that we're going to have a positive x value and a positive y value, right? So everything in this table should be positive. So let's go through one of these, and then I'm going to have you try to fill in the rest and then come back. So we actually just did one of these. We actually did a few of them on your examples and on your try-its. So the try-it that we just finished was for pi over 3, okay, or 60 degrees. So let's take our values from that last try-it and put them in here. Okay, so we came up with sine is equal to square root of 3 over 2. Cosine is 1/2. Tangent is square root of 3. Cosecant is 2 square root of 3 over 3. Secant is 2. And cotangent is square root of 3 over 3. Okay, pause this video, go through and try to fill in the rest of this table and then come back. So let's go ahead and fill in the rest of this table and see how you guys did. Our second example was pi over 6, so let's go ahead and fill those in. The sine of pi over 6 is 1/2. The cosine is square root of 3, that's a square root, over 2. Tangent is square root of 3 over 3. Cosecant is 2. Secant is 2 square root of 3 over 3, and cotangent is square root of 3. Okay, so remember, these are directly related to the pi over 3 ones because they're just the other angles, the opposite angles of each other, right? 30-degree angle is the third angle of a 30, 60, 90, and the 60-degree angle is the third angle. Not the right, so these are opposite of each other, right? You have a 90-degree angle, a 30-degree angle, and a 60-degree angle. They're opposite of each other. Okay, so let's fill in these other ones. Pi over 4, or 45 degrees. You had one of these, but in one of the examples or the try-its today, but we were working in quadrant 4, so we want it for quadrant 1. So let's fill this in. We have positive, everything's going to be positive, square root of 2 over 2. Square root of 2 over 2. Sorry, yeah, remember those are the same because we're working with a 45-degree angle. The tangent is going to be 1. The cosecant is square root of 2. The secant is also square root of 2. And the cotangent is 1. Okay, now 0 degrees and 90 degrees, right? We're working on the axes now. So these are going to be a little bit different. The sine of 0 degrees is 0, right? Because there's no y value. The cosine is 1. The tangent is also 0. The cosecant is undefined. And the secant is 1. And the cotangent is undefined. So those would be when you're dividing by a 0. You can't do that. And so those are undefined. So let's go over to 90 degrees. Okay, so for sine, we have 1. For cosine, we have 0. For tangent, that one is undefined. For cosecant, we have 1. For secant, undefined. And for cotangent, we have 0. Okay, so check your chart, make sure that this is filled in, and once again, I suggest you keep this or put a sticky note so you can find it easy. You're going to want to reference this chart often as you go through this. Check Google Classroom for your assignment. Let me know if you have any questions.